We have an object A here. It has 4 properties: message, list, test, and empty. The value of message is a string, which is a primitive value. List is an array, which is a reference type value. Test is a method, and the value of empty is null. Let's say we want to make a copy of object A. What should we do? The simplest solution is to use the object.assign method. It takes 2 arguments. The first one is the target object, and the second one the source object. We set the target to an empty object and use object A as the source. Every instance properties and methods of object A will be sent into the empty target object. The target object will be returned by the assign method. We receive it using variable b. Now, B is a copy of A. It has the same property and method as A. Its prototype is the same as A as well. But there is a problem with this program. The value of list and test are both reference type values. B is actually sharing the value of list and test with A. For example, if we add a new array element via b.list, then a.list will be affected as well. b.list and a.list point to the same array. The message value is a primitive value. We can only reset its value. We cannot modify its current value. If we give b.message a new value, a.message will not be affected. A function is also a reference type value, but unlike other reference type values like array or object, we cannot modify a function body. We can only replace it with a new one. For example, we assign a new function body to b.test. A.test will still point to the original function body. Using the object.assign method, we can make a copy of an existing object. Only primitive property values will be copied. Reference type property values will be shared, meaning the original object and its copy will share reference type property values. This kind of object copy is called shallow copy. In the next lesson, we will show you how to deep copy an object. Deep copy will also copy reference type property values. The original object and its copy can stay completely independent. If we make changes to one of them, the other one will not be affected.